decreasing, you've got all of those things. So there's 6 different things. So the domain is left and right. So the domain is how far does the graph go to the left and how far does the graph go to the right. So in this case, the domain, how far it goes to the left is -1, -2, -3, -4. That's -5. So the domain goes from -5 all the way across. And if you look at this arrow, it would keep going up and to the right, all the way to infinity. It would just keep on going to the right, to the right, to the right, to the right, to the right. Because that is going up and to the right. So it would keep going forever and ever. So the domain goes from, it stops at -5, and it goes, if you continue it to the right, it would continue all the way to infinity, to the right. So that's left and right. Infinity sign is that sideways 8. That's the domain. The range is how low does the graph go to how high does the graph go. So if you look at this, it's actually kind of tricky. The graph, the lowest point that it goes to is -1, -2, -3, -4, also -5. It's kind of strange that these are the same numbers, but it's okay. The lowest the graph goes to is -5. It never goes any lower than -5. And the highest the graph goes to is, it will keep on going because of the arrow, to infinity. So the range is also -5 to infinity. But the range, remember, is up and down. And the domain, if you remember, is left and right. Okay? So you got to know the difference between the two. Now, x-intercepts, you need to know what's the x and what's the y. The x-intercepts are where it crosses the x-axis. And if you look at this, there are 3 spots where it crosses the x-axis. And so I just have to write down those 3 since I know this is my x-axis. So this one is -2, and I can count over 1, 2, 3, 4, that's 5. And then that last one actually looks like it might be a little bit more than 6. Okay, sure, like 6.5. So I'm going to say -2, 5, and then we'll say 6.5. It's somewhere around there. It's somewhere between 6 and 7. If you picked a number between 6 and 7, I think it would be fine because you would not show that you saw where it crossed. The y-intercept is where it crosses this one. Now, it can cross more than once, but this time it only crosses once. It looks like it's about right here. So if I go up 1, 2, 3, 4, it's between 3 and 4, so we can just say 3.5. So that's where it crosses the y. Okay. Now, the next part you have is you're talking about, we're reading this from the left to the right. So when we talk about intervals, increasing or decreasing, we're always talking about left to right, like kind of how we would read a book. Okay? So from here all the way until here, it is increasing. It's going up. The graph is going up from here all the way so you get here. So this is -1, -2, -3, -4. This is from -5 all the way until you get to 1. So from -5 all the way over to the left until you get to 1, it is going up all the way from -5 to 1. So it is increasing from -5 to 1. Okay? Then at 1, which is right here, it is decreasing until you get to 6. So it is now decreasing from 1 to 6. And then when you get over to 6, 1, 2, 3, 4, 5, 6, we're right here, it is now increasing from 6 till forever, to infinity. So that's another increasing. So again, what is it doing? It's increasing from 5 until you get to, or from -5 until you get to 1. Then it's decreasing from 1 until we get over to 6. Then it's increasing from 6 until forever. So those are our intervals that are increasing and decreasing. Okay, now we get to the second part. It says state the parent function and the transformations for each of the following. So parent functions are the things that they're in your notes. They're actually 2.2, I think. So parent functions are just, that was 2.1. This is 2.2. Parent functions are just the original function. So if I just write y equals x squared, what type of, you want to say what type of function is that?
Quadratic.
That's a quadratic. And you have a list of them. There's all kinds of, there's a list that has all the different ones in their graph. So that is a quadratic. That is the parent function. Okay? And so if I take that, so that's the parent function, x squared. If I look on a graph, again, I could use Desmos, I can use whatever I want. But if I look at this, and you can know it just by knowing it, but if you don't know it for sure, I'm going to give you another way to see it. If I look at y equals x squared, that's the parent function. And then I look at the new function, that's y equals x squared minus 1. What happened? It went from here to here. So I can take it off. So I can say what happened from here to here. From here to here. It moved down. Okay? And it moved down by 1. So that's what that minus 1 is doing. That's called the translation. What happened? It went from here down to here. So it just moved down 1. That would be my translation. Anytime you subtract on the outside, that minus 1, if you add on the outside, you would move up. Since you're subtracting, you move down. So the transformation, what happened from this parent function to get to here, is you move down 1. And that's what we said in transformations earlier in the week. We said, anytime you add or subtract inside, you're moving left or right. Anytime you add or subtract on the outside, you're moving up or down. This is on the outside, so we're moving down 1. This is on the inside, so this is left or right. Now, the parent function for this is just y equals x with the bars there, and those bars stand for absolute value, so that's our parent function. So we know absolute value is the function we're talking about. Okay, so that's our parent function, y equals the absolute value of x. And we want to know, how is this transformed? Well, the 2 is going to change your slope. So we looked at it, and if you looked at, again, it's in your notes we were looking at earlier, if you have a number bigger than 1 in front of it, that's called a stretch. If you have a fraction, a number less than 1, that's called a compression. So this is a stretch of 2. And then the minus 1 on the inside, if you add on the inside, you move left. If you subtract on the inside, you move right. So we're going to go right 1. Now, I can show you on the graph how this happens. So when you're looking at them, you should be able to see the same thing. So when you look at a graph, you say y equals, and you say the absolute value of x. The absolute value bars on Desmos are right here with the A. So the absolute value of x. Then you say y equals 2 absolute value of x minus 1. Now you can see it was here, now it's here. You can see the difference. You can tell that it moved to the right by 1. You can also see that here's my original function, and then here's the new one. You can see that it got steeper. That's called a stretch. So it's stretching towards the y-axis. So it got steeper. It's It's kind of like if you do your arms like that, if you stretch higher, it's going to get steeper. So that's a stretch of 2, and then it's moving right 1. That's how you see it change from red to blue. It moved to the right by 1. Okay? So we get to the next one. The parent function of the next one is still the absolute value of x. It's absolute value 1. So it's still absolute value. And we want to know, how does it move? Okay? So if we want to know how it moves, it's moving by adding on the inside. Well, if you subtract on the inside, you move to the right. So if you add on the inside, you got to move to the left. So the transformation is going to have to be left by 5. And then we learned in the first one, if you subtract on the outside, you're moving down. So there's a -2. It must be moving down. If it would have added, it would be moving up. So this is going to be down 2. Again, if you want to look at the graph on Desmos, you can see it moving left 5 and moving down 2. But that's what happens to it. So you take the regular absolute value equation, and it moves to the left by 5 and then down by 2. So then we go to D. This is going to be just the square root of x. Okay? And that's called a square root function. Square root. So that's a square root function. That's the parent function. So we want to see what changes to get from the square root of x to -3 square root of x. So I'm going to show you again on the graph just so we see it. So square root of x, if you want the square root, it's right here. So square root of x. And then let's say for the other one, we want -3 square root of x. So look at the difference in those two. Square root of x is just this little red curve going up. That's your square root function. It's on your parent functions notes sheet too. Shows that square root function. And then -3 square root of x, look at what it is. So what happened? What changed there? Instead of it going this way, it's going this way. So there's a reflection. It reflects, or it flips is what I like to call it. It flips, right? So it flipped. So now instead of going up, it's going down. And then this 3 is a stretch. It's stretching. It's going further instead of just going smaller up. Okay, so that's what that number in front, remember, does, is stretches it. So it flips and then is stretched by 3. So those are the two things. So what happens, they could call it a reflection. That's another way. So either say flips or reflects. So we'll say flips. That's what that negative in front does. And then is stretched by 3. So those are the transformations that happen there. Okay, so those are the transformations that happen in that